Oh.
Next type of problem for static equilibrium is the beam and wire. So we've got a beam that's attached to the wall, and then there's a wire also holding it up at a 30-degree angle. The mass of the beam is 25 kilograms, and the mass of this weight at the end is 280 kilograms. So we got four forces. One, the force on the wall and the hinge. Halfway across, we count the weight. We've got a weight hanging at this end, and we've got a cord holding it up at the same end. So we can't take the torque from here because we'll have two unknowns over here. So if we take the torque from the right side, these will both be zero because they won't have any distance. So let's do the torque from the right side. So the first thing we're going to hit is halfway across at 1.1. We've got the weight of the beam, 25 times 9.8. That's going to be negative because it's pushing down. And at 2.2, we're going to hit the force on the hinge that's at the wall. That equals 0 because this thing is not moving. They're balanced forces. Okay, so we can move this whole quantity over to the other side, make it positive. 2.2 FH equals 9.8 times 25 times 1.1 equals 269.5. Divided by 2.2. And the force on the hinge is 122.5 newtons. That's pushing upward. Okay, so now we got four forces. We know three of them. We know this one we just solved for it. We know this one, it's 25 times 9.8. This one's 280 times 9.8. What's the force of tension in the wire? Well, what's actually holding this up is the vertical component of the tension in the wire. So let's see how that's going to be quantified. So let's get our forces equal to 0. We've got 122.5. That's this force. It's an upward positive force. Halfway across, we have 25 times 9.8. That's 245. That is pushing downward. At the end of the beam, we have 280 times 9.8. That's 2744. That's also pushing downward. So we don't know what the tension in the wire is, but we know that the vertical component would be the sine of 30 times that. The sine of 30 is 0.5 times the force of tension. This all equals 0. And let's solve for the force of tension. Okay, so I got 122.5 minus 245 minus 2744. So I've got negative 2866.5 plus 0.5 tension equals 0. Move this quantity over here. 0.5 force of tension equals 2866.5. Divide each side by half. Divided by 0.5. And I get the force of tension in the wire is 5733 newtons. So that was the beam and wire problem.